So first thing you should know is that I do record all my lectures. This is because I mean I was doing this before COVID. I actually wrote a hey, I'd like to give a talk about this to an computer science education group back in 2019. I said, hey, we've got a mumps outbreak here on campus. It's an incentive for us to record our lectures because occasionally you get outbreaks on campus. So this means that if you record your lectures, students won't have to come in. They said, and that paper, that proposed talk didn't get accepted. And then COVID happened. And now there's been lots of talks about that. None by me though. So I'm not sore about it, not at all. Anyway, again, just waiting for people to come in. But recording my lectures, I do that as well as opening up Zoom, because if you're sick, I don't want to see your face. Show up on Zoom, don't care. I don't care about absences really. You're sick, stay home. You can either watch the recording, just let me know, or watch the recording later, or come in on jump on the Zoom. Because if you come in and you're sick, you're gonna get your friend sick, and nobody wants to be sick, even if it's just like a cold or something, So, plus recordings are really useful because you want to. Sometimes you miss what I say in your notes, and then it's hard to go back and record it, and it's just a pain. So this gets rid of a lot of kind of issues common issues that students have. So I record my lectures. You can find the recordings over here in the lecture recordings in the center point. And then also over here under the other important links, which will redirect you to that page. Okay. So I suppose I started with this. I'm Professor Rosen, by the way. And welcome back to campus after not being here for a summer. So this is 2168, or at least I hope it is. Otherwise, I'm giving a lecture to a very compliant class that is not 2168. So 2168. So what we're going to be learning this semester is a lot of different data structures. Your computer science curriculum, the computer science curriculum in general, consists of 3 parts, typically spread between 3 or 4 courses, depending on the university in question. The first is basically being able to break down problems into kind of algorithmic steps. Basically, take something that looks like a word problem, break it down into unambiguous statements so that you can turn it into a program, which means learning different programming paradigms. Because if you don't know how to do that with all the other stuff for figuring out, computer science is kind of a pain. The second part of that is this course, which is that a lot of times you've got these problems, and dealing with these problems just simply requires you to organize all this data you're taking in. And it turns out if you manage to organize it, that's probably like 90% of the problem right there. So different ways to organize the data you're taking in, and how to construct these data structures to hold this data. Because again, organization is key. You can basically really make sure that you solve a problem pretty easily. The third part, which is 3223, is the algorithms course, which is basically, well, what if organizing the data isn't just enough? And okay, how do we figure out how long programs take to run, like really, like mathematically speaking? And what about these problems that we can't solve very easily, which are, this class of problems called NP complete? But I get ahead of myself, about a semester ahead. So that's what this course is. I'm going to go ahead and open up the syllabus and go through it with you. And then I will talk, and then we'll get to work on our first homework today. I know that sounds weird, but let me explain in case you've never taken one of my courses. Okay, so, right. So this just simply is all the subjects we're going to be going over. You have probably covered inheritance and array lists with Professor Fiore in 1068. Second week is going to be going over, first week is going over and is reviewing inheritance and stuff like that. The second week, we're going to be learning array lists, but we're doing it in conjunction with a programming tool called generics, which is extremely powerful, extremely useful, and it really helps you making self-inflicted errors. After that, we'll take a look at time complexity, which is how long do these programs take to run? linked lists, stacks, queues, then we'll hit recursion. Trees, we'll cover heaps, Huffman trees, sorting algorithms, hash tables, and graphs. The big thing to know is, aside from this lecture, the lectures will be flipped. So what does that mean? That means that the entire idea of a normal lecture is kind of not optimal, because you're sitting in front of a class for an hour, 20 minutes, and listening to a professor drone on, maybe not about the most interesting subject, very easy to get distracted about the human attention span is about 15 minutes on average. And not only that, like, that's the easy stuff, the general introduction to the material. They give you the hard stuff on the homework because you have to solve the hard stuff in order to really learn it. And that's when you need the professor's help the most. So the idea of a flipped lecture is that we flip that. I've recorded the lectures for each week in advance. They've been up for a couple years now. I'm pretty pleased with the way that it's turned out. And this is not in addition to any other kind of lectures you'd have to watch or anything like this. These are basically, you will have about less than 2 hours a week of video to watch. The videos are split up into basically anywhere between 5 to 20 minutes long, depending on the content. So very easy to watch one, take a break, go on to another, right? The idea here is that you just simply watch them at your leisure. And then in exchange for doing that outside of class, you come into class and you work on what would normally be the homework. So essentially, our lectures turn into additional lab time for you to work, for you to collaborate, for you to ask for help. This means that a lot of your work gets done in class. Some of it will, yeah, you're gonna have to work outside of class on this homework too, but a lot of it gets done in here. And generally the students' responses have been positive because, you know, when you get stuck into a wall, typically what you do is email me, and then you'd have to wait for me to check my email, and then you'd have to wait for me to deem it important enough for me to reply to you. So, and then I have to figure out what the problem is, because the email might be like, I don't quite understand what you're talking about. Can you please go into more detail? And then you have to repeat this process again. Instead, during the lecture, you wait for me to get to you, or you raise your hand, I come over, I say, aha, you made this mistake because I've seen this mistake being made by 50 other students because I teach this course a lot. So we can fix that basically in like 5 minutes, in 5 seconds to 5 minutes, rather than beating your head against the problem for about 5 hours. It's that's very common with computer science. All right. So the time and place for this lecture is here. You found it, congratulations. I'm not really sure why we have to put this in the syllabus when it's in your schedule and you can figure it out. If I get sick, I will be holding my lecture via Zoom, or the lecture session via Zoom. So that, or if something comes up and I need to be able to, and like say we have a massive snowstorm, and even though campus is technically open, it's a bit of a pain to get to campus, and I don't necessarily want my students driving in unsafe situations, I might say, okay, let's do it over Zoom. I try to be flexible like that. Okay. Your labs are Friday, 9 a.m., which is not the most awesome time, I know. And both lab 1 and 2 are in the same room, which is the biology life science room 137. So, so you'll basically have 2 TAs in the same room as you. All right, so the prereq for this course is having a C or better in 1166 and 1068. If you did get a C, unless it's like for a very specific reason that like what you did wrong and it's just because stuff was messed up during that semester, you might want to consider like seriously reviewing your stuff if you got a C in that course. All right, so for this course, a reliable laptop is strongly recommended because we're doing a lot of coding during our lectures. If you do not own a laptop, first off, you have 2 options. One, work with somebody who does, because I'm a big fan of students working together. I don't mind that at all. That's weird. Okay. The second thing is that like at the bottom of the steps right over here, like on the first floor, when you come in, there's a laptop kiosk where you could just simply scan your card and and basically borrow a laptop. Those are freely available for students. This is useful to know if your laptop basically is out of commission for a bit. All right. So, and the key word here is reliable. I cannot emphasize enough, if using your computer or laptop is a painful experience where it takes forever to do anything, you will suffer physically, emotionally, and mentally, and academically in this class. It just happens. Please reread the last point. You will also experience torment, lamentations, wailing, gnashing of teeth, etc., etc. Okay. And then I've copied this from basically the syllabus recommendations that were sent out about how you can get, there's a technology assistance fund that if you don't have the money, we'll figure there's some funds available, different ways to get internet service. If you really need help finding a laptop, I am more than happy to talk shop about that. Generally speaking, $400 laptops are actually pretty decent for getting the work you need done. They might be a bit heavier than you want, but they're pretty good. Okay. So the textbook is Data Structures, Abstractions, and Design using 3rd edition. And I'll be honest, I don't really care if you get it or not. It's a good book. It's written by 2 former professors who were here, who taught this class before. It's a good textbook. And I go through, and unlike a lot of other textbooks you get, I pretty much go over every chapter except for 9, and I only do that because I don't have enough time in the semester. It's really good. I recommend it, but you don't need it. A lot of the stuff is I'll go over pretty much everything in the lectures. And I know if I told you to get it anyway, like half of you would download it on the internet anyway, because textbooks are expensive. I'm currently working on a free alternative textbook for a course, but it turns out writing is hard. All right, so office hours. Those are times that are set aside for you to meet with me or a TA. So please refer to the Canvas front page to find the link to the office hours. So you can find the link to the office hours here, or here, and I'm going to try to embed the page here down below everything as well. Or you can click on it in the syllabus over here. What that will do is that all of my office hours will be held over Zoom, and it's a page I've set up where basically you'll see what time is available for you. Right now, my times for office hours are currently in flux, but I do have a few hours scheduled. So I might change up when I'm doing because my kid's starting kindergarten in 2 weeks. So I have no idea how that's going to affect my schedule because that's new. But as you can see over here, like on Wednesday, I've got some time on Wednesday set up in the evening as well as on Monday. And that's just me for times. You can meet with me or any of the TAs. And if none of these times work for you, by the way, please send me an email. These are only the times I have set specifically aside to meet with students. Make sense? All right, so if none of these hours work for you, let me know. I'll probably add more hours as I figure out what my as I coordinate with my wife and figure out my kid's schedule for kindergarten, but you can either select to meet with, and for you, you'll be selecting to meet for 2168 or for general advice. Right? General advice being, okay, any suggestions for courses to take? What do you think about this topic? Hey, I need help picking out a laptop. Any kind of thing that you think I might be able to help with. Okay. So the biggest thing is that be sure to select a person on that page and be sure to get there will be an email sent out which Zoom link to use. So be sure to, click on the appropriate person you signed up for, because that's the most common error where basically people think they scheduled with me, but they scheduled with TA instead. All right. So, you're expected to attend your lectures or labs. If you can't make it, email me and try to attend via Zoom. Otherwise, watch the lecture recording, which is generally not that long. This first one's long because I'm going over the syllabus and it's the first semester. Right? If you're sick, I already said this, or you suspect you're sick, just don't come to class. I don't even care if it's an exam. Just email me. Okay. Okay. If you get really stressed out this semester or have some significant stress or worry, changes in mood, or problems eating, or finding housing, or problems sleeping, whether because I'm doing this to you because of this course or because life is terrible, please reach out to me so that we can make accommodations for you. I'll be able to point you in the direction of your services, of any services you need, as well as, more importantly, I'll be able to like set up like, okay, so let's make an alternate schedule for you to try to figure out the work. The sooner you reach out to me, the sooner I can come up with like a solution for you, which at worst case would be an incomplete with like a specific deadlines. Okay. But you know, but if you wait until like the last week of the semester, it's very hard for me to do anything. Okay. If you have any kind of accommodation based on a disability or similar thing or similar need, basically, you know, work through DRS and let me know what accommodations you need. I haven't found an unreasonable accommodation yet. So, so whatever that is, just let me know. Okay, grading. The quizzes might go down a bit, but that's okay. So the letter grading is generally, right, if you get it, if your raw score is a 90 or above, it's an A, 80 or above, it's a B, 70 or above, it's a C, so on and so forth, exactly like you'd expect. There will be a minor curve at the end. And generally what that means is that I will use the minuses and the pluses to extend the grade ranges. So like in the previous semester, in 88.5 to right below a 90, that was an A minus, right? So that's, and then like the 87, people who got 87s got a B plus. And then, so, and that kind of pattern extended its way down into the C range. There's extra credit in a lot of assignments, including one already up, and there's an extra credit assignment already up. There is, I usually drop an assignment, by the way. Labs and assignments are the same thing, so just keep that in mind. There are some labs I won't drop, but those are clearly laid out in like the drop policy. So here's the grade breakdown. I'll go through each of these. Quizzes, labs and assignments, exam 1, exam 2, and the final exam. Quizzes are not scary quizzes. They are self-assessments, which means that you take them unproctored, any resource you want, including friends. And in fact, and the reason I don't care is because they are mainly there for you to see, am I like keeping up with the course and the course material? Do I understand it? I'll probably be lowering this to 5%. But it's kind of my way of giving you a way to get free points. And generally, if you don't do well on the quiz, or even if you do, you know, almost perfectly on the quiz, you'll have a chance to retake it. The only like penalty for retaking it is that you have to like wait 15 minutes between attempts, you know, because again, I want you to understand the material. Labs and assignments. So to turn in your lab, so each week, or in some weeks you'll have 2 weeks to work on stuff, we'll have an assignment. Okay, turning these assignments in is a 2-part process. The first is you submit it to Canvas like you would normally for anything. The next is that you need to demo it to me or a TA. This means coming up to me during class or office hours, or going to your TA during the lab or during their office hours, and basically running your code and answering a few questions we might have about this or explaining this. It's not a particularly stressful process, but I do want you to get used to explaining your code to other people, because when you go for job interviews, that's a very common thing you're going to have to do. Okay. So like the most common question, like for a question in assignment 2, question 5, I'll have a specific question about like, why did you need to solve the problem this way? Because otherwise it's not going to work, is the answer. But why? So another thing is that we will accept your late work. The late penalty is 5 points per day. That's it. So if it's 3 days late, it's an 85. The maximum late penalty is 50 points. So you can turn in anything for half credit, even if it's like close to the end of the semester. Although I'll get into that, though, you'll want to have made sure you got an okay from me first. Because I do have some caveats to prevent some abuse of the system. Okay, quizzes, right? Low stakes, unproctored assessments of your mastering the course. They have a due date and can be started anytime prior to the due date. You'll have the opportunity to almost immediately retake most quizzes. So the last thing I want to say about the late policy is late grades for assignments, those are based on when you submitted it, not when you demo it. So after you submit your assignment, you have up to 2 weeks to demo it. Okay. After that, you'll need permission from me to demo it. Okay. And the reason I have this clause is first off, I'll almost always say yes. But the reason I have this clause is that I used to have people coming in until the end of the semester, waiting until the end of the semester to demo everything, and then they couldn't explain anything. And it was a painful process for everybody involved because I'm like, really, you're wasting my time, and the students like sweating like crazy because they're super nervous and can't remember anything. So don't do that. That's why I have this clause in there. Okay. Okay. Exams are the biggest change this semester. It'll be something new for you. So our exam will be a two-phase examination. Anybody ever take a two-phase or two-stage exam? Well, that will be new for you as well. Something new we're trying this semester. First off, your exams are taken in lab. The exam block is an hour and 50 minutes long, which means there's 110 minutes. The first 70 minutes will be dedicated to an exam, a normal exam. So that will be worth 80 to 90% of your overall score. It's just a standard exam. You take it. I'm still debating whether it's going to be electronic or if it's going to be on paper. It will at least be open note. Okay, open note on paper. It will at least be that. I'm still going to figure out the specifics. It depends on how easy it is for me to implement this on Canvas, you know? Okay, so that is worth 80 to 90% of your score. The second part is that immediately after the individual exam is finished, we will collect your exams, and then you'll split up into groups of 3 or 4, and you will take a group exam, which consists of identical or nearly identical problems as a group. Generally, it won't be the entire exam. It will be like a small subset of the problems, because of course you have a shorter time period, and generally the more difficult ones. But the idea here is that between like 3 or 4 of you, you'll probably be able to figure out how to get a perfect score on that. So now I know that when I say group work, immediately there's shudder and wailing and gnashing of teeth mentally inside all of you. That is why we have the caveat. Your overall score cannot be lower than the individual portion. That means that the group portion cannot hurt your grade. It can only help it. Okay, so don't be afraid of the group portion because it's only going to improve your grade. So you'll split up in size 3 or 4. There's going to be 1 exam copy per group. So 3 to 4 of you are going to be working on 1 exam and turning in 1 exam. This is because that if I give you all exams again, you're just going to work together and not really talk with each other, because the purpose of this is I want you to talk. So why am I doing this? Well, during an exam, that is kind of when you're most wired to learn. Okay, that is when you have the most incentive to learn something you don't know, because the stakes are high. And the problems have a very clear kind of, this is what you want to do. So there's also, as you well know, there's kind of an energy that occurs after an exam that basically permeates everybody, which is, what did you get on this? You know, what did you get on problem 5? What did you get on problem 6? Everybody wants to share that, you know? And so part of that is harnessing that to kind of teach that, to kind of give a learning opportunity to everybody for these problems. Because for the people who got it wrong, they learn what was, or parts of it wrong, they learn what was wrong, and they learn how to correct it immediately, and they get credit for correcting it immediately. For the people who got it right, they master the material, because the way to master material is by teaching it. So there's a lot of incentive for me to do this. It's to help improve your learning. This is the first semester I'm trying this out. So it's a bit of an experiment. That's part, but I mean, like, again, the experiment's not going to hurt you. And when I say experiment, I mean, I'm like trying it out, not like I'm collecting research on you guys, you know. I'm like, just want to see what your opinions are of this. Okay. Yes.
So is it possible to get like 100% on the exam just from the individual portion?
Yes.
Alone? Okay. Yes.
It is. You could, if you score 100 on, if you score perfectly on the individual portion, then you know the group part probably won't have any impact on your grade. Right now, the only caveat here is that if you've got some kind of accommodation for extended time, please speak with me so that we can figure out what the best solution is for you to participate in this, or if you are even, or if you can, or if we need to like create some other situation for you to basically participate in this. Okay. So any questions about this process though? The first exam will be 80% single person and 20% group portion. This is generally because for my first exam, I've generally seen that exam is regarded as more difficult than the second exam, which generally has like an 87% average on the score. Because the material, if you've made it to exam 2 without dropping the class, generally you've got a pretty good way of the idea of how the mechanics of the data structures work. Final exam, I don't put the date in because I figure it out the same way you do, which is clicking on the link to get to the registrar. Okay, apparently I have to fix that link, whatever. Okay, but they put up a final exam schedule every semester. And so I'll figure that out. Generally, it's a common final, so I don't know the specifics yet. I don't think that one will be a group one, but I might be able to convince the other professors to do that. The final has a reputation. Yes.
It is really unclear on the schedule, like when the final is.
I'll figure it out. Generally, it's during one of those group exam days. Traditionally, it's been the Tuesday. So you have your last week of classes, right? So you have that last day of class on Monday. Then you have Tuesday and Wednesday as study days. And then you have your first batch of exams. And then the next week you have your next batch of exams, and then everything is done. Typically, it happens on that second week's Tuesday, which is what makes that, and that is what makes the exam difficult, because it's basically when you're all out of energy. So just keep that in mind. Don't neglect studying for that exam. One thing you should know, though, is if you have more than 2 finals on the same day, then you're allowed to tell your professors no. You're supposed to be able to work with your professors to find a separate time to take one of those exams. If I'm one of those professors, I'll be more than willing to accommodate you. And if I'm not one of those professors and your professors are being jerks, that's when you contact the dean of students, because they will help you sort that out. So don't take 3 exams in one day, because that's not fun. Okay. Academic honesty. I have a long thing about academic honesty here. I'm generally I've been very good at catching cheaters in the past. But I try to be reasonable about it. The general rule of thumb is that if you are the person needing help, you can show other people your code. But if you are helping other people, don't show people your code. Okay, that is the general rule of thumb. Basically, don't show answers, but if you're trying to figure out what you got wrong, yeah, should definitely share your code, because that's the easiest way for people to help you. All right, so that basically means that I really encourage collaboration. Okay. And in general, if you're not sure, ask me. If you feel like if you committed plagiarism and then are like, well, that was a terrible decision, send me an email within 72 hours. That's my regret clause. If you commit plagiarism, send me an email within 72 hours of committing that offense, and I will not write you up. You will get a 0 on the assignment, but I won't write you up, because that write-up is an annoying process for everybody involved. Okay, so anyway, now that I've killed the mood there, here's what I consider reasonable. Communicating with classmates about assignments in English, Klingon, Elvish, Esperanto, Spanish, any language, don't care. You can communicate however you want. Discussing the course material with others in order to understand it better, helping a classmate identify a bug in his or her code in person or online by viewing, compiling, or running his or her code, even on your own computer. You're allowed to have other people's code on your computer when you're trying to help them. Incorporating a few lines of code that you find online or elsewhere, provided that those lines are not themselves solutions. So like say for a first problem, like there's a Fox and Rabbit program, don't go online and try to find somebody's complete solution and just dump it into your assignment. That's not that. But if you're trying to do something that's hey, is there an easy way to check to see if the contents of 2 lists to see if they're equal? Can I do that in 1 line? And somebody found out a clever way to do that? Yeah, totally. You can copy that. And then all you have to do is cite it. And I'm not talking MLA or Chicago format. I'm saying in comments, give me a link to where you found it. That's all you have to do to cite it. Okay. Sending or showing when in doubt, cite it. I will, if you cite something, the worst I'll tell you to do is just do it yourself. That is the worst that will happen. Okay. Sending or showing code you've written to someone else, possibly a classmate, so they can help you identify a bug. Sharing those lines on Stack Overflow or somewhere, that's perfectly acceptable. Again, you're trying to identify a bug. Trying to figure out, find a way to solve it on the internet. Working with a tutor to help you solve these problems. Whiteboarding it to solve a problem. Again, those are all reasonable things. Okay, what's not reasonable? Going out and just finding the answer. We don't want to do that. Just don't. You miss a learning opportunity. If you're having trouble, email me and I will be more than happy to sit down with you over Zoom and walk you through a solution or to a solution as the need may be, because I want you to learn. Asking a classmate to see his or her solution to a problem set before you okay, hey, suppose Alice goes to Betsy. Hey, Betsy, what did you get? Can I see all your problems? Can I see your answers? No, that's generally unreasonable. This isn't really relevant to this one, which is decompiling or deobfuscating or disassembling solutions because of the way Java works. All right, not citing something you found online. And generally when this happens, it's finding a code that addresses the question on the exam and failing to cite it would violate this policy. That was specifically when we had our exams, when I allowed internet uses on the exam. Finding code online that you think might address the question at hand and blindly copy and paste it onto the exam when it doesn't actually address the question is a great way to violate the policy and to make me angry. Because that's happened a number of times in CIS 1051, where I would give a question and then people would try to answer a different version of the question. So showing your classmate a solution to the problem when it's they and not you who are struggling to solve it, paying somebody to do it for you, to literally do it for you, splitting up the, so if there's 5 sub problems, splitting it up, saying I'm doing problems 1 and 2 and you can do 3 and 4 and we'll work on 5 together. No, just work on them all together. Okay, that's what I want you to do. I don't want you to basically split it up like that. That's just not cool. Again, you're missing out on the learning opportunity. Computer science, the programming specifically, the only way you get better at it is practice. Just like a musical instrument, there's no shortcuts. You have to practice. And homework is the way I can enforce that practicing. Okay. So, and then looking, hey, can I see your homework? I'm just going to make a couple changes to it. Don't do that. Computer science is pattern recognition is a subdomain of computer science. Do not do this. Seriously, do not do it. All right, that came from Harvard CS50, which syllabus, which I adapted here because they had some great stuff in there. Also, you have rights and responsibilities as a student. You can find those rights linked here. Things like not taking more than 2 exams on the same day. Those are right, But so you should probably go through that paper, even though it's boring. All right. So any questions about the way this course is going to be run? That took a while, but whatever. Okay. So let's go ahead and talk about our first homework. So first and foremost, I do not care in the slightest what tool you use to write your code in. I personally use IntelliJ. You can use VS Code, you can use Eclipse, you can use NetBeans, you can use Vim, you can use Emacs. I don't really care what you use so long as it works for you. If it doesn't work for you, find a different tool. That's really what it comes down to. Okay. So new project. Let's go ahead and next, Fox and Rabbit Ball 2022. So first off, I'm just going to create this folder for assignment. So to find this assignment, by the way, and any other things for this class, go over here in the modules. That's basically going to be the main way you navigate through this course. Right, start here, meet the professor if you want to know more about me, which this video, by the way, this third point, Crash Course on Data Structures. Crash Course is a YouTube channel. They did an entire series on computer science. This one specifically basically will cover a lot of what we'll be doing in this course in about 10 minutes. So it's a very good summary of what you're going to be learning. Yeah, they have good animations too. Next, if you aren't sure how to install Java, because Professor Fiore during the pandemic, he did a lot of stuff with an online web-based Java thing. So I have those instructions in case you want to know how to install an open source version of Java and how to set up IntelliJ. Because, you know, that's useful to know. Next, so you can go through next. By the way, it's the first week of school. You have plenty of time. 15 extra credit points. It has no due date other than at the end of the semester. 15 points for basically learning how to do regular expressions. Regular expressions takes about 2 hours to learn really well, and they save you so much time. It's ridiculous. It's such a useful tool, but it doesn't really fit into the problem, into CS curriculum, except for automata theory. Yes.
We have to demo the.
Yes. Yes, just so I can simply check to make sure that your regular expressions kind of are kosher. So you can also find your assignments under assignments, but over here, right? So typically it will work like this. The overview, which I rarely filled out, and then you'll have a playlist of videos, right? Almost everything embedded into Canvas is a playlist. Just click on the top right over here to see all the videos in that playlist. And so some of these videos are like, generally the playlist works is that there's a pretty nice professional looking video that's about 2 to 3 minutes long where I'll go over the week's content. This first week is object-oriented programming review. So all the stuff you will learn during spring, sorry, back in spring, if you took it during the spring. So, and then there's basically a couple, and then over here, like this video is like 3 minutes. So this video is 3 minutes. This video is 12 minutes. So they vary in length, but none of them are excessively long. Every week, I guarantee it will be less than 2 hours of video watching. Okay. So, and then, so the worth knowing is instance of and for each, which may not have been covered in your Java course. Okay. So there's, and then after the videos, we will typically have there's a quiz generally. And then the assignment. I'll figure out what the due date for the quiz is. I just have to put that in. So this assignment is due next Monday. If we need more time, I'll give more time, but no worries about it because you're going to have today to get started on it, Thursday to work on it, and all of lab to work on it as well. Okay. So it's composed of 2 parts, which is a PDF, I'm going to go over it right now without referencing to the PDF. So if you need to, you can, if you need a reference on paper and you learn better that way, you can, or if you just like that reinforcement. And then there's the source code over here. Okay. This is actually the hardest part of this assignment for a lot of students, which is downloading the source code, which works as follows. Hit the download button. Put it on your desktop or wherever you want to put it, okay? So what we're going to need to do is we are going to need to unzip this file, okay? And how this process works is different depending on your IDE of choice. So over here we have, let's see, not starter files. So let me go ahead, sort by item type, hunt.zip. So I will go ahead and extract all to its own folder over here. We've got that folder, and inside of it, we have a bunch of Java files. It's a fairly large program, but don't let that intimidate you. You will only concern yourself with coding one file that's already written for you. You have to code a specific method in them. So what we're going to do is that we are going to select all of these. Okay, and this is the part where people mess up. I'm just going to hit copy over here, or you could, Control C or Command V or Command C, depending on your thing, or you could right click and select copy. And then notice I created the project first. Notice I created an empty project first. Okay. That's key. If you try to do this, you want to create that empty project. And then I paste everything into this SRC folder here. Let me go ahead and give me a second. Settings. UI size. Let's bump that up to an obscene level. Okay, there you go. SRC folder over there. It's the blue folder. Okay, and this works the same way in Eclipse, by the way, and in NetBeans. You want to paste it into this SRC folder, not outside of it, inside of it, because SRC is source. So that's where all the source code goes. If it's not there, your computer's not going to read the IntelliJ or your IDE is not going to read it. So we've got a bunch of programs. Sorry, a bunch of things in here, and we've got two things with main methods. We can tell they've got main methods because they've got a green arrow next to them. And that means, so over here, the first one we'll run is rabbit hunt. It will show up as a completely white screen at first. That's okay. It'll show up like this, but as soon as you hit one of the buttons, which is like run, it will start running. So what is this? This is a really graphically simple simulation. Okay. There are three types of objects on this grid. There's the red dot, which is the fox, the brown, which is the rabbit, and then the green splashes are bushes. And this is a simulation. The fox and the rabbit both have a goal. The fox's job is to eat the rabbit by landing on his face, which he just did. That's the fox's job. The rabbit's goal is to survive, is to not get eaten, which he does if he doesn't get eaten for 100 turns. The fox ate the rabbit here after 46 turns. Okay. The board configuration is created randomly upon is created randomly each time. And this controls the speed over here. And the game is asynchronous, or rather it's turn-based, meaning they don't take their turns at the same time, which is important for developing a strategy for this. Okay. Now you may notice that the fox is almost always catching the rabbit, and this is because the rabbit is really dumb. Let's open up the rabbit source code and see how dumb he is. Okay, the rabbit has a couple of different things. Do people in the back need me to up the size to this? No, can you see it? Okay, no problem for me to do so. Okay, public rabbit model int row. Okay, this just simply creates this is just simply the constructor, calls the previous constructor by calling super. We know that the rabbit is a type of animal based on the extend statement, but let's look at the decide move. That seems relevant because that's how, and you'd be correct in assuming that is how it figures out how it's going to move. It returns an int, and the int corresponds to a direction that it wants to go. And decide move, as you can see here, random. You don't really even need to read the rest. It's just selecting a move. It's just making a move at random in a random direction, which is effectively staying still, but worse. Because you're just moving without any kind of motion. On average, it gets out to random, but you might but if you're moving and random, that means you might accidentally jump into the jaws of death. So I'll go into that. So the other thing we have here is the grader. And that figures out your grade for this assignment. It's done as follows. We run the grader, and it runs 300 times. This is the only other thing other than rabbit you're allowed to alter, which is altering the number of trials you run, the number of games. So it plays 300 or however many games you specify silently. The more games you play, the less random the results are going to be. So here I'll run it 30,000 times, and we'll see that the rabbit escapes 199 times out of 30,000, or effectively 0% of the time. So your grade is 0. Your grade is proportional to your survival rate. Specifically, I implement what's called a square root curve. Square root curve is, your grade is determined as follows, which is, let's see, your grade is the square root of your survival rate multiplied by 10, meaning that getting an 81% survival rate will get a 90. Make sense? Means that you'll get very quick things, but very diminishing returns very quickly. So the only way to get 100, by the way, on this is to cheat. So, and to be really clever about the way you cheat. It's kind of or rather, I should say, it's not specifically cheating, but it's, in the words of an old movie, the the only winning move is not to play. So, but there are some crazy strategies that can get into the 99% survival rate because a lot of this is luck based. So a couple times you're just going to get unlucky. Now, that being said, it's actually not too, once you understand this problem, it's not too hard to get a 90% or so survival rate with just like 10 to 15 lines of code once you understand what you're doing here. Okay. So let's go through all these pieces of the program. So first off, let me just, we were running a GUI, and you may not have had experience with a GUI, which is, or GUI, a graphical user interface, right? May have been a while since you heard that term. Okay, and it's using a very old but very solid paradigm here, which is called the model view controller paradigm, where they split up the job of the graphic user interface into 3 distinct components. The model, which is the internal components of the code. Basically, it runs completely independent of the graphics. It's basically all the data. That's how we're able to hit the run button, and it just runs without running the GUI because it doesn't really need the GUI. You're a human, you need the GUI. Okay. The view is this window over here where we actually see what the action is going on. And so it's this window, and it's this frame in the window. That's our view. The controller is all this stuff down here where we can interact with the view. Basically changing the speed, saying I'd like to run this, I'd like to stop it, I'd like to resume it. There's also a useful button over here called step, which we'll be getting into, which allows us to show how it's working step by step. And now it appears that our fox is shooting lasers. It is not shooting lasers. It is actually using the look function, which we will get into. Okay. So the controller, definitely don't need to concern yourself with it at all, because that has no bearing on how the program's going to interact, right? Literally over here is defining buttons and stuff. Same with the view. It's just saying, okay, here's the field and stuff. Here's how I draw all these things. Okay. So really it's all, so the rest of the things we have to concern ourselves with. Although some things are very simple. As you can see, the bush over here is just simply defined as a thing, right? Without any real code in it. They're just here, okay? So the model defines a lot of stuff. Specifically, the model holds stuff like the field, the number of rows and columns. It holds a copy of the rabbit and a copy of the fox, as well as where the fox is. And notice that those things are all private. So there is a rule here, and the rule is you can only change stuff in the rabbit program, only in the rabbit file. So you can't go into the model and change it so that, you know, the game lasts only 0 turns. Okay, you can't change stuff in the model like that. Okay, it has a Boolean rabbit is alive, a Boolean game is over, and states are taken, static number of columns, static number of rows. And then it also has these other things where basically, so all the directions are coded to an integer. So 0 is north, 1 is northeast, 2 is east, but that's hard to remember. So instead of trying to remember that, you can figure that out by basically saying, like over here, model dot northeast, right? You don't have to remember that northeast is 1. You just have to remember that that NE is northeast. Okay. So basically it's got a lot of predefined things, including min direction, which is 0, and max direction, which will be 7, which is northwest. It goes clockwise, right? Over here, it goes through all the directions clockwise. We also have 8, which represents not moving. Okay. And then there's some useful functions in here. The most useful of which we will get into later, is the we've already seen random, but specifically it is the turn function, which given a direction allows you to ask for a direction that's some amount of 45 degrees off of this direction. Now, the reason this one is useful is because it allows you to, you don't have to like say, okay, if the fox is to the north of me, I have to go southeast, or if it's to the east of me, it needs to go northwest, you know. You don't have to you don't have to do that. Model.turn allows you to just simply use I as a direction and figure it out. Otherwise, without using model.turn, you can do it, but it's going to be 8 times as long because you have 8 times as many directions to figure out. Okay. So there's a bunch of stuff here, and we can get a good idea of how these things are used in the Fox program. So we can actually look at the Fox's strategy here. Now, I will preface this by saying that the Fox's strategy is that of a predator. It is a very different objective than what your prey animal has to do. The fox has to hunt. The prey is happy just sitting down and conserving energy. In fact, that's a pretty good strategy. I'll go over the 2 strategies that that I found have been successful in a bit. But we have a bunch of variables over here. And we have its constructor. It sets up a current or an initial current direction. And the way it figures out its move is that it sets can see rabbit down to false, right? Because it doesn't know if it can see the rabbit until it looks for him. So at the beginning of each turn, what it does is that it has this loop over here. If you were going to copy anything from the Fox's code, it would be something. It would be not what's inside. It would be just the loop itself and the if statement modified to being the Fox, because you want to do kind of different things over here. But it says for I in model.min direction, which is 0, less than or equal to model.max direction. By the way, just a side note over here, I use some funky things with fonts. Specifically, I use ligatures with I use a font that exploits the ligature setting over here. I'm using Cascadia Code, which is Microsoft developed font. The reason I mentioned this is because when you abuse ligatures in font settings, you can do things like this and produce an actual less than or equal to sign. But if I were to copy that, it would still be the less than sign and the equal sign. It's like if you have finish, right? In some fonts, the top of the F that curls over will be on top of the dot of the I. In some fonts, that's ligatures. It's a very kind of niche kind of knowledge there. But point being is that if you're wondering why I have this thing here and it takes up 2 spaces, that's why. Similar with the equal to sign. I find it very useful. Some people hate it. They hated it. It's the worst thing ever, right? But this long equals is actually just equals equals. Makes it easier for me to read, especially if I do not equals. So just keep that in mind. So for I in model in direction, while it's less than or equal to max direction, go through all of them and look and see if it's the rabbit. So we can see this in the code for rabbit hunt as this happens. Okay. So I'll open up rabbit hunt and I will hit run. I'll hit step and it will look for the rabbit and then it will move. So the look function looks for the rabbit. And then, by the way, it's got some code that it performs if it hasn't seen the rabbit or doesn't see the rabbit, which is what that current direction is. It keeps trying to go in a direction. Notice that the bushes block line of sight. That's what the role of the bushes are, right? So it's going, keeps going, and it will keep pacing back and forth until it finds that rabbit, which we'll know when we see it change. Well, here it's bouncing off randomly. Let's see. Yep, and there it makes a beeline because it found it. Let's replay that. Run. So you can replay this if you're interested. So step. So here, right? Okay, it sees the rabbit, so it moves towards the rabbit. Now it knew the rabbit was in this location last, so it will select to do that. So let's go over that code. Once it sees the rabbit, it stores that information, the direction to the rabbit and how far it is from it. So if it's seen the rabbit, if I have seen the rabbit, which is not can see the rabbit now, but basically when you see it, you say, can I see the rabbit now? And have I seen the rabbit? Like, can I see now as mean, have I seen it this turn? Have I seen the rabbit is, have I seen it, you know, and am I currently in the chase mode? So if I'm in the chase mode As long as I think I'm still not where the rabbit should be, I go towards the rabbit. I return direction to the rabbit. That's how you move. You return what direction you want to go in. If you return an illegal direction, you will just simply stay put. You will not crash the program. Otherwise, rabbit was here. Where did he go? Basically, if you get to the spot and the rabbit somehow got away, you set rabbit, have I seen the rabbit false? And you set the current direction you're going to being a random direction. So the next batch of code is, what if I haven't seen the rabbit at all? Well, if you haven't seen the rabbit at all, you'll have this block which says, hey, if you can move in the current direction, that's useful, can move, asking if you can move in a certain direction, I do so. Otherwise, I'm going to try to go around it I'm going to move diagonally to the right. Otherwise, I'm going to move diagonally relatively to the left. That's what the model.turn does. It moves it in a relative direction. We can see this again in this initial, oops, okay. We had a perfect configuration in the beginning. So let's see. So run. That was very quick. All right, so let's go ahead and step through this. So it was trying to go in this direction. It couldn't, I think. So it just stepped to the right. Oh, no, it was going in this direction. So now it's going to try to go forward over here. But if it can't go diagonal go diagonal over here, it's going to try to go clockwise instead, which means it goes down. So it basically tries to deal with going along edges or going around bushes. Okay. But what if it can't bounce off? What if it can't do that? If it can't move around its obstacle, it will choose another random direction and go in that way. So basically paces back and forth randomly. Does that make sense? Okay. So for the so what I want you to try to do in these last 20 minutes of class, I know I've eaten up a lot of time here, but here's kind of the steps I want us to get at. So in this time, for just this class, I want you to I want you to try to install this program, get it running in your IDE. Just simply run it, being able to run the rabbit hunt. So that you can come to class on Thursday and we can work on this. On Thursday, about midway through, I want you to be at an area where we can get maybe a 40% survival rate, about halfway through that. If you aren't there, I will give you the beginnings of a solution. The two strategies for this are exploiting line of sight and kiting. For those of you unfamiliar with that term, kiting is an MMORPG term where one player hits the enemy in question and basically says, look at me, chase me, while everybody else does damage over time effects so that we don't get aggro. And so basically one person basically runs while that monster is poisoned and then eventually drops out of poison. Here, basically the idea here is, since you're moving at the same speed, there's no reason that he should be able to catch you if you know the map. So that way is much more difficult to do, I should say. The kiting strategy is much, much more difficult. Exploiting line of sight's easy. All right. So I'm going to go ahead and stop sharing, stop recording, and let you get ready. If you are having